All right, everybody, welcome. If you're here for the pre-show, glad you're with us early. As we've been doing for the last couple of weeks, we're gonna just go over some of the cyber news from the last week. So, kicking us off, really interesting story from Intel. So Intel obviously is a chip maker. They make the central processing unit in most PCs out there these days. Not all of them. They have a competitor in AMD, and they also don't make the processors in most mobile devices, right? Those are different kinds of chips. But Intel commands a large amount of the market, so they're a massive corporation, and they have a lot of proprietary technology to protect, some of which got leaked this week. 20 gigabytes worth of information was disclosed in a data dump, and really, really interesting material inside of this data dump. So what do we have? We have designs for the processors themselves, and you have to remember that these designs we're talking about technology that is in the nanometers in scale, right? We're really talking about nearly at the atomic level in terms of scale. Really, really complex construction and fabrication for these chips. So a lot of that was disclosed, along with some other technical specifications. And really interesting, inside of some of these specifications were documented backdoors for the technology. Now, when you hear backdoor, you might think about an actual backdoor to like your house. That's not what we're talking about. But you also might think about something that is added by an intelligence organization, right? Or like a nation state saying, we're going to put a backdoor into your device so that we can remote into it and spy on you. That actually did happen a number of years ago, where it turned out that the NSA had been putting surveillance devices into equipment from, I believe it was Cisco, and shipping those devices out. So that was kind of an interesting story. But more likely what's going on here is that these backdoors are used by engineers. They're not used by malicious actors necessarily. But when you're working on technology like this, you often will need to get information out that the average user wouldn't. So you create a port for yourself and allow information to come out of that port. Not a physical port necessarily, but just a way to access that information. And sometimes those things don't get removed before the product ships. So I think that's really what we're looking at here. But more to come on the Intel story. Really, really interesting disclosure. We don't get a lot from Intel that way, and we almost never get data dumps from really serious technology companies this way. Like imagine if the source code for Windows leaked online. That would be massive, right? So a fun story to follow. It was luckily a quieter week on the ransomware data dump side of things, although we do know that Garmin, for example, definitely paid money to get its operations back online. So that story has kind of come to a resolution, although again, paying is a little bit of a dodgy circumstance, or a dodgy situation, because when you pay, you encourage ransomware attackers to attack other people, or you again, because you've demonstrated that you will pay. All right. Something really cool is happening right now, which is the biggest cybersecurity, information security conference of the year, DEFCON. Now, of course, because of COVID-19, we're not in Vegas, where the conference usually takes place. We're all at our individual residences, but there are some advantages to this. There's a lot that usually would be paid that in this case is free, that you can go and participate in. I might be plugging that a little bit more later in the stream, but there are so many great talks. There are so many activities for you to explore if you're interested in this field, if you're interested in cybersecurity or information security, right? Not just cyber. There's just so much for you to do, and All of it is streaming on Twitch. So if you go to info.defcon.org, you can find the whole schedule and find out where to go. So I highly recommend giving that a shot. In particular, there is a certain kind of activity that I think is very, very helpful for learning new skills in this field, including programming, called CTFs, or Capture the Flags. These are competitions where the organizers set up a series of increasingly difficult challenges, and you are looking for flags, right? There is a file on a system that you have to hack into in order to obtain, or there's a program that you have to decipher in order to figure out what it's trying to do, and that's the flag. So I've been doing CTFs for the last, I don't know, year and a half or so, and I can tell you that just throwing yourself at them and working with others who know what they're doing and can teach you is an amazing experience, and highly worth it. When I started, I was super nervous. I didn't really want to participate in CTFs. I'm not that outgoing of a person, generally speaking, but I took the leap, and I do think that my skills grew because of it. So if you're interested in these things at all, even just to see what kind of things we get up to, the CTFs, there was one last couple of days, which was the Red Team Village CTF. That was for offensive security skills, so like really trying to break into stuff. There's another one going on right now, which is the Application Security CTF, which I'll be taking a shot at later today. I'll maybe throw some stuff on Twitter about how that's going. Not solutions, of course, because we have to keep that secret, but it's a good time. So why don't you join me? All right. With that out of the way, it is 10 o'clock, so let's get started. Welcome back to Hack Summer. My name is Taggart. You can follow me on Twitter there, and if it's not too much trouble and you're liking what we're doing here, give us a like, give us a subscribe, just so more people can find the stream, more people can find these videos and learn a new skill for themselves, better themselves over this weird summer. So we're talking about Python. We're talking about cybersecurity through Python. Last time we started making a game, a familiar game probably for most of us, rock, paper, scissors, and we were encoding the rules of that game into Python. Now, when we revisit the code, we'll see that by the end of what we did, we hadn't really gotten every feature that we wanted yet, which is why we're revisiting it today, things like saving high scores. But in addition, it got messy, right? There's so much code that goes into even a simple game like rock, paper, scissors. I think for sure we broke 100 lines of code. And so what we're going to do today is we're going to reorganize the code a little bit to clarify what we're doing, and also to take advantage of some other features of the Python language. So let's talk a little bit about one of the important features that we're going to visit today, having done dictionaries last time. So we know about key value pairs now, a new data type that allows us to structure data where we access a key and we request a key from an object and the value is returned rather than looking through every entry in a list, for example. So that's one kind of structured data. There's another kind of structured data that is not, it's bigger than a data type, really. And the reason that it's not included in the 4 core structures of programming, variables, conditionals, loops, and functions, is because not every language has this structure, but it's important nonetheless, especially in Python. That structure is called classes. Okay, what do we mean by classes? We don't mean like courses or sitting at in a classroom. But what we mean by classes are like categories of objects. And in fact, as we'll talk about, that idea of objects is core to what we're going to do with classes. I think this is really easy to explain by example. So classes help us reason about our code in a human way. Rather than thinking about just code as functions or, series of instructions for the computer, Classes allow us to group the information that we're working with into objects and types of objects the way that we do in our everyday life, right? We look around and we see stuff, right? Like this chair. And so this chair, like what makes it a chair? Well, it's got 4 legs, right? Most chairs have 4 legs. It has a back. If it didn't have a back, would it be a stool? I think so, right? But there's something that defines chairness for this chair. And you could call that an archetype. You could call it a Platonic ideal of a chair, right? Whatever that is, that kind of that root concept of chairness. And then this chair that we're looking at here is an example of that chairness, right? It's one instance of chairness. That is what we're doing with classes. So with classes, we define that archetype. We define that rule for what a type of object is supposed to look like. And then we can make multiple instances of that class with specific characteristics and properties. For example, we have this chair here. We could maybe also have a blue chair, right? We could have 100 different chairs, right? But they all are chairs because they share common characteristics. This method of programming is referred to as object-oriented programming, where we group our code into objects or classes that we reason about in a much more human way. And it's shortened to OOP, or OOP. Now, Python is a really flexible language. It'll let you program kind of in whatever style you want. If you want to do just straight imperative, just writing instructions, you can do that. If you want to write functional programming, where your code is a series of functions composed one after another, you can do that too. And in full disclosure, that's usually how I like to program, but not always, because some problems don't fit that paradigm. And if you want to program in object-oriented programming, Python will let you do it too. As a matter of fact, it was kind of built for it. So we're going to explore classes first, and then we will go and revisit rock, paper, scissors and see what we can do with classes and objects to make the program better. And also, we're going to extend the feature set. All right, so let's go ahead and get right into our coding. All right, so I have started a new REPL in Replit, as we've done so many times before. In this case, we're in a bash REPL. Okay, so instead of Python, we're going to do it this way, the main.sh, because I want us to get comfortable using the command line as well as Python. So I'm going to type bash over on the right-hand side to get that full shell experience. And I'm going to touch class demo.py to create the Python file. And then just as a safety, right? Just as a safety, in case I accidentally click run rather than doing the Python run command over here, I'm going to change my main.sh, which is the kind of hardwired program to run in this REPL. We're going to turn that over to Python class demo.py. And we'll just move over to the class demo.py. Okay. So now we've talked a little bit about how classes are like prototypes or archetypes. So let's make a class for a common object, an object that we are familiar with. Let's start maybe with a car. All right, so we're going to learn some new syntax for this. To start, we're going to define the car class with the class keyword and then capital C and then AR. And then, of course, we're going to have a colon because we're going to indent our code underneath of it. What this tells Python is that all of the code inside of this block is going to refer to the car class. Now that capital C is the convention for class names. We capitalize, finally, we capitalize something in Python to indicate that it is a class. All right, now we've talked about the idea that classes are archetypes, right? But remember, and we talked about how any, for example, for chairs, any individual chair is an instance of that archetype or that class. So let's keep that in mind, where we have a class, right? And then we have an object or an instance of that class. So the class actually has to have a factory, kind of. It has to have a function that creates new instances of the class. And that is called a constructor. Generally speaking, that factory is called a constructor. So a constructor creates new class instances, which we refer to as objects. And that's where object-oriented programming comes from. Every language has a different way of describing their constructor. In Python, we do it this way. So we're going to say def, so it is a function, and then two underscores, underscore, underscore, init, two underscores, and then parentheses. Now, inside the parentheses, it takes one argument for sure, which is self, and you have to call it self. Okay? But you see how it turned blue, right? It is a reserved word. But then it also takes any other argument that you would send to the constructor to make a new instance of a car or whatever your object is. So this is when we need to start thinking about what data we want to contain inside of our object. What defines a car? Well, it has four wheels, right? They all have four wheels. They all have an engine. What are some things that differentiate them, that are different about them, but they all have those same definable characteristics? They all have a make, they all have a model, they all have a color, right? So let's start with make and model. So we're going to send a make in there, right? And we're going to send a model in there. Why is make being weird? Let's make a reserved word. And we'll find out. Ah, there we go. No, it was just being strange. So self, you can see, is a reserved word. It's not italicized, but make and model are not reserved words, but they are arguments to the constructor. They're italicized. So to assign whatever we want for our new car to the object, we have to, inside the constructor function, we have to assign this information to self. And we've seen the dot notation before, right? We've seen things like inside of string formatting, dot format, right? And we put in something in there. So we've seen dot notation before, or random dot choice, right? Where we have that dot and then something inside of it. Well, this is where it kind of comes from, right? It comes from accessing properties of objects. So to assign the make and model to the specific instance of the car, we have to do something like this. Self.make equals make. So it's taking whatever information is coming into the constructor and then reassigning it to itself, right? To the instance of the object. Self.model equals model. Okay. Let's go ahead and over in the right-hand side, just with that much done, let's fire up the Python interpreter with just Python, right? And then let's import the car module or the car class. And we're going to do that this way. From class demo, import. Now we could either import star or import car. And I want to import car because that's the specific thing I want to get. Okay. So if I ask for type car with a capital C, it tells me that it's a class of type. So I haven't created anything yet with it. Let's make something. I'm not gonna lie, I know they're not great for the environment, but I love muscle cars. I can't help it. I just do. So let's go with and pony cars too. So let's go with an old school, Ford Mustang. So let's go with stang equals, and then here's how we make a new object in Python. Okay, we call the class. It looks like calling a function, right? Where it's the capital C car, and then it's going to be parentheses, and then inside we give it not self, but the make and the model that we want to assign to that specific object. So in this case, it would be Ford Mustang. Now, if I just ask for stang back, check it out. It doesn't actually print out anything useful for me. It just tells me that it's a class demo .car object, right? So it came from the class demo module, right? That file, and it is a car from the car class. You might wonder what this is. This crazy long string of numbers and letters is the actual address in the computer's memory where it's living. We don't really need to worry about this right now, but in case you were wondering what that is, that's what it is. It's where in memory the object is living. Okay, so that's cool, I guess. We have more that we should probably do. So let's try, for example, to access some of its properties. If we wanted to find out what the make was, we could do stang.make, and that tells us that it is Ford. Stang.model, of course, tells us that it's the Mustang. Now, what happens if we print it? Just let's throw it at print and see what happens. Right, it's actually not that helpful. And the reason that is true is because just like init has these double underscores and it's kind of a magic method for classes, Python has other magic methods that we use to print stuff or to add things or subtract them. And so because the secret is that everything in Python is an object. So if we wanted to be able to print out the car in any meaningful way, we would actually have to create that method inside of the class. So let's go ahead and exit out of the interpreter for now. Come back over to the class. Now, I just want to also call something out. I've been using the terms properties and methods, and I want to make sure we understand their definitions. A property of an object is a characteristic. And you might call it like a scalar or static. Yeah, not static because it can change, but a scalar characteristic. So it's something like that, something that describes it, like something that it is. Right? Something the object is. I think that's a really good way of thinking of it. So make and model, these are properties. Methods are functions attached to the object, or something the object does. So let's give it a property, or sorry, let's give it a method. Let's give it a way to print itself out. And we're going to do that by creating the underscore stir. So underscore underscore. This is sometimes these two underscores are referred to dunders for double underscore. So dunder, str, dunder, and then whoops, and then parentheses, and then every single method of a class has to take as its first argument self, because that's how the function references parts of the object. Now, inside of the stir method, we don't print Okay, we return the string that is going to be printed. So in this case, we're going to return .format self.make self.model. So now it's going to print out like Ford Mustang, right? In fact, let's go ahead and add one more property to it, which is going to be the year. And we do the same thing here. Self.year is year. All right, let's come back over into our Python interpreter on the right-hand side. And we're going to do the same thing. We're going to, from class demo, import car. By the way, did you notice how the Python interpreter saved the history, even though I exited out? Pretty helpful. Okay, now let's remake the Mustang. In this case, we have to give it new arguments, right? Because now we added the year. So now it's a car, and I'm going to give it the best year of the Mustang, which is the 1967 Ford Mustang. Okay, let's make another car. So let's go ahead and go with yeah, let's do Knight Rider. So we're going to do kit equals car. So that's going to be the, I believe it was the 1982 Pontiac Firebird. Okay, now if I print the Mustang this time, so it gives me the Ford Mustang. What did I forget to do? I forgot to put the self.make, I forgot to add the year into our print string. But that's okay. We get the idea. And the same thing with kit, right? If we were to print kit out, it's Pontiac Firebird. So we've given the object a way to represent itself as a string. And that's pretty much all there is to it for the base concept of classes. I do want to visit one more important idea. And what we're going to be talking about here are, so far in terms of methods, we've talked about methods that are attached to the object itself, right? So this stir method, right, it's going to print out the particular string representation of the object it's attached to, right? But the class can also have just functions that are attached to itself. And that's really, really helpful sometimes. So these are instance methods or object methods. There are also what are called class methods. Class methods attach to the class itself. So for example, let's say we wanted to keep track of how many cars we made. I don't know why, but let's say we did. We could have a variable inside of the class car. This isn't part of any given object. It's just part of the class called total cars and equals 0, right? So then in the init function, when we make a new car, we actually would have to go after that. We would have to go car dot total cars plus equals 1. So we're actually modifying the total cars value inside of the car. Now, what if we wanted to go get it, right? Well, let's run just this much. Let's exit out of our interpreter and see where we are. So I'm just restarting the Python interpreter. And let's go ahead and re-import the module. So if I ask for car.total cars tells me that it's 0. Okay, cool. So now if I wanted to make a new car, so let's go ahead and make kit again. And by the way, since we restarted, it prints out with a year, so that's a little bit more handy. Now let's go check out car.total cars. Now it's 1. Okay, so this isn't a class method yet. This is just a class variable. If I wanted to have a method attached to it, right? I could say something like this. I could create a new function called getTotalCars. And when we attach a method to a class, it doesn't take self because there is no object instance. It takes a variable referred to as CLS, or the class itself. And you say return CLS.totalCars. Now there's a little bit of a trick to this, which is that in order to tell Python that you want this to be a class method, you have to use what's called you don't have to, there's another way to do it, but the easiest way to do it is to use what's called a decorator. Now, take a moment. If you're feeling overwhelmed, pause this, go back and review it. But if you're good, just know that we're going to introduce a little bit of new syntax here that looks totally different than anything we've done. These decorators are really, really handy, and I wanted to introduce them now, but they do look very different from what we've done so far. So to really attach this function as a class method to car, what we're going to do is we're going to use @classMethod. And what that does is it tells Python, hey, this method is not attached to any function or any instance of the object, it's attached to the class itself. Okay, with that, let's go ahead and restart the interpreter. Re-import our module. If this is getting annoying to you, good, because I wanted to make that point before we introduce next week how I like to write code for Python without having to constantly restart the interpreter. So car.getTotalCars is 0. So that's a really safe way of doing it. And we're going to take advantage of this class method approach when we revisit rock, paper, scissors. So let's talk a little bit about what we want to do to refactor rock, paper, scissors. So refactoring is when we take code and change its shape a little bit to either improve its functionality or make it more readable. And in this case, we're going to add features. One of the most important things we want to do when we refactor rock, paper, scissors here is make it easier to test and fix. And so in part, we're going to be modularizing the code by taking the game that we've written. We have, what is our game? Our game is the main game loop, if you recall, and then a whole bunch of helper functions. Okay, what we're going to do is we're going to create a game class that bundles all of this stuff together in a logical grouping so that these functions can work together meaningfully. And it'll also make it easier to kind of reference information back and forth inside of the game class. We're also going to add some features, right? So we want to save data, not the officer on the Enterprise D, but we want to save our high scores. Now, there are a lot of different ways we can do that. We've seen how we can write to files, right? We've read from files, but we're going to write files a different way this time. We're going to, rather than writing plain text, we're going to write what's called serialized data. Basically, what we want to do is we want to take the dictionary of high scores that we're going to track, and we're going to save it as a loadable Python object in a file. And to do that, we're going to use a library called Pickle. I know, but it is what it is. And what Pickle does is it serializes Python data for us. Now, it's not secure, and that's actually important for us because we're going to mess with it. So we're going to build RPS using Pickle and our classes, and then we're going to hack the high score because Pickle is not secure, and it's important to know that. So let's go ahead and get started. Okay, up first, let's go ahead, if you have your RPS REPL, go ahead and get it up. If you don't, that's totally fine, but I am going to be referencing it. So I'm going to go ahead and duplicate this tab so that we kind of have both going on. So here's what we've done so far with RPS. We've encoded the rules of the game inside of this dictionary, beats, and we have a whole bunch of functions, right? Print choices, get player choice, get computer choice, all of these choices. And then we have the game loop, right? Where we define the order of play, we have the score here, and then we're printing the choices. Let's actually go ahead and run this, right? So if we do Python rps.py, let's see what it looks like. So we choose one, rock. Oh yeah, one, cool. Paper, I lost. I'm one and one, that's not too bad. And then if I do Q to quit, right, it ends, and then it tells me what the final score was. Now what I want to do first is save that information. To save that information, I would need to first import the Pickle library. Okay. And then I need a save high score function. But I need a lot of things, actually. Let's think about what we would need for high scores. We would need to load the high scores. Let's actually go ahead and list them out here. What do we need? We need to you know what? Sorry, I'm going to do this as a multi-line comment just so it's easier to type it out. Boy, Replit doesn't get multi-line comments. Okay, so high scores. What do we need to do? The first thing we need to do is load the high scores. And if there are no high scores, we need to return something useful anyway. Okay, we need to load that. So we'll try that. What else do we need to do? We need to be able to check if the score is new high score, right? So however we decide to do that, we have to do that check. And then we have to update the high score. So we're going to transform this into a class-based program. But before we do that, let's deal with just this problem, because we know we want to add this feature even before we go to classes. Okay. Let's start with loading the high score. To do that, we need to specify where the high score is going to be saved. I'm going to define that in a constant variable for the program. Constant variable is kind of an oxymoron, but whatever. Call it high scores file. And it's going to be highscores.pickle. And let's go ahead and write our load high scores function. def load high scores. And we're not doing any of that self stuff yet, right? We're just going and writing this the way that we normally would. Okay, well, let's think about what do we need to do to load a high score. What is necessary? We're going to attempt to open the high score file. And we're going to do this with an opening syntax that we've seen before, but we haven't played with too much. Which is, if you remember before, we would do like hs file equals open and then the file name, right? And then we'd use this and then hsfile.close to close the file again. But there's a more elegant syntax in Python, so we're going to use that, which is inside of the try block, we're going to do with and then open. We're going to open the high scores file. And we have to open it in a very special way. Rather than just opening it by default in read mode, we have to read bytes. So it's not just a text string. It's not plain text that Pickle encodes information in. It's bytes, like the actual bytes of information that the computer reads to decode the strings. So we have to read it in bytes mode. And then we'll refer to that opened file as f. And then we will say high scores equals pickle dot load from the file. Now that might not work. What if the file isn't there? Like it isn't there right now. Or what if there's something wrong with the file? Whatever it is. Let's give it a way to save itself with the accept block, which we learned last time. So again, we attempt this thing. If it errors out, we kick over to the accept block. So it's almost like an if-else, but for handling errors. Accept. So if something goes wrong with loading the file or assigning that to the high scores variable, we're going to say high scores is an empty dictionary with the curly braces. And then we get to show a new part of the try except block, which is the finally component. You don't have to have the finally component, but it's really helpful. I love using the finally component. So finally, anything you put inside the finally section of the try except finally block will execute no matter what happened, right? So whether it's try succeeded or you got to the exception, the finally component will run regardless. So that's exactly what we want, because no matter what happens with high scores here, right, whether we loaded it from the file or it's an empty dictionary, no matter what, we're going to return high scores. Okay. So we have load high scores. What else do we need to do? We need to check if the score is a new high score. How do we do that? How do we check high score? Let's write the function as check high score, right? But let's think about how we would do it. To check the high score, we have to give this function both the high scores and the current score. Now you might be thinking, well, wait a minute, why are we referring to it as high scores rather than high score? Because isn't there only one so far? Which, yeah, kind of. We are going to add the feature that we can have more than one player. So that's kind of what we're aiming for. So that's why it's called high scores at the moment. How do we determine high score? So the way that I was thinking about it is if the wins minus the losses is greater, right? So, right, you have your number of wins in the score dictionary, right? Then you have the number of losses. Ties we won't count. So what we're going to look for is the difference between wins and losses. If that number is larger than the current one, then you have the high score. So, okay, so check high score. You see how much code this is at this point, even for small programs like this, and that's why it's really important to organize your code into these functions that you can test individually. By the way, fun replit tip. You may have noticed these little minuses next to blocks of code. So you can collapse functions if you don't need to read them. See that? And then you can click the plus again to expand them. Most modern text editors have this capability, and it can be really helpful if you are dealing with a very large file. Okay, let's go ahead and write this check high score code. We're going to attempt to say weighted high score is the high scores wins minus the high scores losses. And then we'll say weighted current is score wins minus score losses. And so again, this is just a check, right? All it has to do is check whether the current score is the new high score. So it's going to return true or false. Now we could say if weighted current is greater than weighted high, return true, else return false. But that's actually not necessary. We can do this in a much cleaner way. What we can do is we can actually just return that. Let's get rid of this. Because remember, this inequality, this comparison, will evaluate to either true or false. So that means we don't have to do an inherent if-else. We're going to just return whether this is true or false. Okay, you might have wondered why we threw this all inside of a try block. What could go wrong? Well, remember, when we load the high score might be an empty dictionary. Now, we could have initialized it to, wins, losses, and ties. We could have done that. But having it as an empty dictionary actually makes it a little bit easier here, because if we try to access this and there's a key error, guess what we know? We know that there's no high score, which means our score is necessarily the high score. Which means we can do except, and remember that when we try to access something in a dictionary and the key isn't there, it's a key error. So if the key error happens, we return true. That's why we did it that way. Okay, so we've done the load high scores, we've done the check high score, and then we're going to update the high score. That's our last piece here. How do we do that? Well, again, we're going to do the with open. I got to write the function signature first. So update high scores, sorry. And because we only update it if there's a new high score, right, we're going to send the score in there. And we're going to do that same with open as we did before. There's that high scores file. Now we're going to open it, in this case, in write bytes mode, which is the WB, as F. And then we do pickle dot, I didn't write this module, but it's dump, pickle dot dump. And what do we dump? We dump the score. So how do we start using this thing? Down in the game loop, we're going to start adding some options here. So first of all, let's we have to check for the high score, right? So every time through the game, right, when the game is over. So right here, we're going to, after we say final score, print score. Then well, actually, we need to we need to load the high score, don't we? Sorry about the sirens. So we're going to get the high score. And then down here, we're going to check it. If check the high score, remember we sent those into our function, right? The high score and the score. So if that's true, we're going to print new high score. We'll do that new line thing. And then we will update the high score. Did I keep my update high scores? Yes, update high scores with the score. Okay, I think that's good for at least a test run through this. Let's go ahead and give it a shot. Tie, that doesn't help me. Okay, I lost. I'd like to get a win to get a real high score, but it doesn't really matter because it's the first game. Okay, cool. New high score, and then dump required missing argument. Hey, check it out. The high scores.pickle file got created, so that part worked. What did I forget? Dump requires missing argument file. So an update high score, I'm pretty sure I forgot to. Yeah. And it tells me the position too. Require argument file, position 2. So I'm dumping score to the file F. That was silly. I should have known that. Okay, let's try that one more time. So I'm running the program. Hey, I won first time. I'm going to quit. And I have a new high score. Now, I haven't added the print high scores capability, and there's a reason for that. But let's take a look at where we are now. I'm gonna just start the Python interpreter because I want to show you what's in this highscores.pickle file. If we look at it, it's nonsense. I mean, you can kind of read it, right? Because there are some readable strings. But the rest of it is unreadable because it's machine information. It's not for people. But check this out. Let's import Pickle into our Python interpreter on the right. And then let's do that same thing with open. In this case, we'll just manually say highscores.pickle as f. Ooh, what did I forget? I have to read it in bytes mode. Score equals pickle.load from the file. Right? Now, check out score. There it is. I have loaded the score, which means a couple things. One, I could hack it if I wanted, right? I could just say like score wins equals 9999999, right? And then I could do like, I could rewrite it. Pickle.dump score f. And now I have modified the score for the game, just with a little bit of extra Python. So the ability to, I wanted to make the point that Pickle is it's not human readable. That doesn't mean it's secure. It just means that it's designed for Python to read, not for us. And it is super easy to mess with that. So if you ever run into that situation where you're serializing data like we are with Pickle, just keep in mind that somebody else can easily deserialize it. And that's actually a really important thing when we're writing our programs. Always think about security, real security versus security by obscurity, which is not a thing. I promise you somebody will find what you're trying to hide or trying to be clever about. Okay. We haven't totally done the high scores feature because I'm going to wait until we start classifying this thing, but let's go ahead and kind of start fresh a little bit. So I'm going to make a new REPL over here. So I'm going to make a new bash REPL. I'm going to call it RPS 00. So what we want to do is we're going to do a little bit of copy pasta here. But we're going to take some of the functions that we did in the RPS code, and we're going to refactor this to use classes the way that we were talking about. We're definitely not going to be done at 11 or at the top of the hour. We're going to probably go to 15 the way that we did before. So this will be available, of course, to replay if you need to bounce then. By the way, just a reminder, if you're coming in late, thanks for joining us. If you haven't liked or subscribed to the channel, if you haven't liked this video or subscribed to the channel, please do. Really appreciate it. It helps me out. It helps other people find this series so they can learn Python and cybersecurity as well. All right, let's classify this thing. Let's think about what we would need. What we're going to do first is we're going to break this out into two different files, okay? The first file is going to be rps.py. The second file, sorry, I'm going to do this with the command line. The second file is going to be called game.py. Why? Because most of this, all of this, is not like the game loop, right? Is kind of all of this is about the game itself, or the game loop. And when we think about it, when we run the game, what are we doing? We're creating an instance of a game. So we're going to put that in its own module. And then the rps.py file over here is going to just be about running the game. And this is going to add a little bit more flexibility for us, including the ability to add player names. So you'll see how we do that in just a second. Let's start by kind of calling our shot a little bit. We're going to write this a little bit backwards. So in rps.py, we're going to have a very, very short function called main. That looks a little bit like this. So the first thing we know is that we're going to do from game import game. So we know that we're going to be writing the game class in here. And in fact, let's start that over in game.py by saying class game. And let's just say pass for right now, meaning we're going to do this later. We're going to implement this later, but for now, don't yell at us. By the way, we also know that for this module, we're going to have to import random and import Pickle for the computer choices. And that's all we're going to do for the game class right now. Let's come back over to rps.py. So we're importing the game module. From the game lowercase module, we're importing proper the game class. Okay. Let's see here. Good. Sorry, just checking my notes. There we go. Okay. So what we're going to do is we're going to actually ask the game to print its own menu. So first we're going to write our main function. And let's just pass right there. And then we know that at the very bottom of this code, we're going to execute the main function. Okay. The order of our play changes a little bit here because we're adding a layer. Rather than just running through the game, we're going to add like a welcome to the game. We're going to have like a new game, show high scores, quit menu. Okay. We haven't made that menu yet. So that's going to be the first new thing that we do. To do that, we're going to write the game print menu class method. Now we haven't written this yet. So if we try to run rps.py, oops, Python rps.py, it yells at me saying game has no attribute print menu. Let's give it one. The first thing we're going to do is we're going to give it menu options. So we're inside the game class, menu options. And it's going to be a dictionary. The first one is going to be new game. And that is, notice, no strings for the key. It's just the integer 1. 2 is going to be high scores. 3 is going to be quit. Right here, let's also do the print menu class method. So remember that to write a class method, a method attached to the class itself, not an instance of the class, we use the class method decorator. Then we write the function, which takes CLS as an argument. So how are we going to do this? We're going to say, like, basically choose choose one, right? And it's going to look like or just choose, I guess, a little bit less of an order. For so for O, if we want, just for option, or M if you want, in CLS.menu options, because again, we can attach anything that we attach to the class here, we're going to have in that CLS argument to the function. So when we loop through dictionaries, right, we always get the keys. So we can print like so. Something, colon something, and we're going to use the format method of the string. That's where that comes from. So it's going to be the key, right? And then we're going to get that again, CLS.menu options, and then M. All right, let's try just that much now that we have the print menu. And check it out. We've got our menu printing out. So far, so good. Let's go back over to our main loop here. Let's go ahead and get a choice. The choice equals, we're going to get user input, so it's going to be something like your choice. But remember that our keys were integers, right? We want them to type integers. We could have made them strings. I just prefer, if you don't have to have something be a string, I prefer it not to be. So we're going to convert that into an integer right here so that they match. And then we say if choice equals 1, we're going to make a new game. And we'll leave that alone for just a second. If the choice equals 2, which was high scores, we're going to do print the high scores. And if the choice was 3, then they can quit, right? Oh, by the way, let's put a pass inside of each of these just so, again, it doesn't yell at us when we try to run the code. So if the choice equals 3, they want to quit. We'll print bye. And then we oh, what did I forget? I was like, break. All of this needs to be inside of an infinite loop, right? Just like we did before with our game loop. There we go. Much better. So then if they quit, we break out of the loop and then the function ends, right? All good. Finally, if that wasn't what they chose, right? They chose like 4 or something else, then we're gonna print not a choice. And then the loop continues. Let's just try that out here. So new game, right, doesn't do anything because we passed, right? We didn't do anything there. High scores, same thing, but the game didn't crash, so all good. And then quit actually quits. So we're doing well so far. Okay. Let's talk about making the new game. If you remember from our object-oriented demo from the car, right, we need a constructor. If we want to have an instance of the game, we need a constructor. So let's go ahead and make that constructor. The constructor for the game, and every object in Python is the dunder init, right? Methods, including the constructor, that are attached to objects take self as their first argument. Now, what information do we need to give to the new game? I think that we should give it the score, the starting score, which is, nothing. And then we have to give it also the player, because we're going to add players. And the high scores, right? And just to be clear, we're going to save the high scores a little bit differently in this version of the game. Because we're going to be asking for player names, we're going to store the scores under the player name, right? So each player can have their own high score. Okay, let's go ahead and write this constructor. And we're gonna do a bit of a hack. So what we're gonna do is, instead of like having separate code in the game loop here to ask for the player name and do all that stuff, we're gonna contain all of that inside the class. Okay, so watch what we do here. We're not going to send any arguments into the constructor for this. It's kind of a fun trick. I like doing it this way when possible. So we're going to assign the player to the object, but what is it? Well, it's going to be game.getPlayerName. We haven't written that yet. Let's go ahead and kind of call our shot with that, though, because it's going to be a class method. Whoops, not print menu again. Get player name. And it's essentially going to be return input, enter player name. Now, technically, it doesn't have to be a class method because we're not using anything else in the class. We could make this something else called a static method, which is still attached to the class but doesn't need this. But we're going to leave it alone for now, just for simplicity. But just know that so static methods are attached to classes, but they don't have to access any class information. They're just in there for logical purposes, organizational purposes. Class methods are in the class because there's information in the class that it needs to get at, right? Like menu options here. And then there are instance methods like init or everything else we do with the game that are attached to the instance of the object. Okay, so we're getting the player name. Let's also create something called the init score. This should look familiar. And ties. Okay. Self.score equals game.init score. So you see the interplay here between the class itself and the instance of the class, right? This specific game that we're starting, and how it's really useful to organize all of our information this way. Okay, finally, we're going to get the high scores. Now, this one, same thing. We definitely need to write the load high scores function. I'm going to add a little bit of information here, which is the high scores file, just like we did before, right? High scores.pickle. And I do this just so that I don't have to keep rewriting this. Now, this is where we're going to do a little copy pasta here. Let's go ahead and get our load high scores function from our old version of the code, right? Let's copy this over. And make sure your sometimes when you copy, the indentation's a little bit funky, so make sure that it's correct. I just need to indent everything but that. And then we're going to need to decorate this with a class method. Load high scores CLS. And then we're just going to add like the CLS dot on top of onto that high scores file constant. And that's it. Our class method is now created for loading high scores. I'm going to go ahead and collapse that down so that we don't have to read it. Same thing with print menu and get player name. And actually, our constructor as well. We have written all three of those. Okay, so look, we've gotten the player going. So a new game is created when we do this. So coming back over to the RPS.py, the thing that we're using to run the game, what we're going to do is, if we want to start a new game, we're going to say new game equals game. That capital G, right? It kicks off the constructor from the game class to make a new game. And then we're going to, this is the next thing we're going to do, we're going to convert the game loop from our old code over. So it's going to be a method attached to the object. So we can say new game dot game loop. Let's go make, let's actually go convert over some of our other helper functions that we know we're going to need, as well as write this game loop. So first off, let's go ahead and write def game loop, which takes self as the argument. And let's just write pass for now, because we don't have to write anything else. Okay, let's see what else we need. What else do we need in terms of class methods, or in terms of instance methods? Well, we know that we're going to have to get the player. We're going to have to get the player choice and the computer choice. So let's go ahead and grab those. Get player choice and get computer choice. Now, these could be part of the instance of the object, but they don't have to be. They can be part of the class. They can be class methods because they don't have to access any special information about the instance of the game, right? These functions, as we've written them, don't at all care about the information. And in fact, they could be static methods because they don't care about anything. Well, get player choice could be. Get computer choice definitely has to be a class method because, look, we're accessing beats for this one, right? And beats, as we know, oh, we need to give it beats again. Might be useful if we included the rules of the game, huh? So for get computer choice, in this case, because it's a class method, we're going to do CLS, and then we access the beats variable through that class. And then we're doing the same thing, it's just that we're organizing it inside of this class this way. Just a reminder, if you're joining us live, if you do have questions, feel free to throw them in the chat. And if we are going a little quick, that's understandable. Feel free to rewatch this, slow it down, take your time. But we're getting to the home stretch here. So just a few other things that we're going to need. So we have the print menu, we have, very good. Let's go ahead and let's do print high scores and print score. So for the print score, which we want to do every time through the loop, right? That's going to be a class method too. And the reason why we make them class methods rather than the instance methods like init and game loop is because it saves memory, right? Because the Python only has to load it once. Now in this case, it doesn't really matter because there's only going to be one game, is what we call a singleton, but I still wanted to make this organizational distinction clear. Okay, so print score is pretty much exactly the same. And again, one of those where it could be a static method rather than a class method because it is not using anything from the class itself. Oh, we haven't done print choices. That's easy enough. That is also going to be, I'm going to put it up with the other prints. That is also going to be a class method. I know this seems like a lot of kind of tedious work, welcome to programming, to refactor this as a class. You'll see that there are some advantages, and also I want to get used to using classes. So for in beats, we know that this is attached to the class, so this one actually does need to use that cls.beats. Okay, there's print choices. We have our print menu. Let's also do print high scores. Now this is going to be a new one because we haven't done this yet, right? Or quite this way, because we're changing the way that high scores work. So this is going to take class as the argument, of course. And high scores, whatever they are. Now again, this one really could be part of the instance itself, and we'll get to the instance methods like right now. But first, this is going to be fun because high scores. So the way that high scores are organized, it is a dictionary that has first player names as keys, and then inside of the player key, there's going to be the wins, the losses, right? So we just have to keep that in mind for printing the high scores. If we say for player, or for P, if you want, in high scores, we're going to print the name of the player. And then, this is why I love doing things this way, we get to do this. cls.print score with the score attached to that player. So we're actually making high scores rely on the print score method. How cool is that? We don't have to rewrite that code. We're making these two functions work together because the shape of the information coming from this high score is exactly what print score uses anyway. Let's also decorate this just a little bit more, just for a little bit of just for fun. Okay. All right, so we have print score, we have choices, computer choice. Let's, you know what, let's write a real quick get, oh, we did have get player choice. Perfect. Okay, I think we're about ready to write our main game loop, which means we're going to come all the way down here to our game loop and start writing some stuff. And this is where it really becomes nice and clean. So here we're going to do our infinite loop. So if you're following, we have an infinite loop within an infinite loop because we're inside of one here, right? We're inside of an infinite loop inside the main, right? And then we're inside of another one here. The first thing we do, of course, is print our choices. Game.print choices. And then we'll say choice is why we did this, right? Game.get player choice. Just nice and clean, just nice and clean. And then we do our check just like we did before, right? If choice equals Q, we're gonna print good game and check this out. Okay, so we also can give the name of the player. We can actually say it because it's attached to the object, right? When we created this instance of the game, we went and got the player's name. So we have it available for us in self.player. So we're going to say good game, player. And then we'll print the final score, finale score, final score. And then game.print score, self.score. So we're telling, this is a class method, right? Because it doesn't need any information, or we're using it for a bunch of different stuff, but we can send our own score over to it and it will print out the score appropriately. And that's exactly what we want to do. There was one class method or instance method that we still needed to do. Which is check high score. Now this one's different enough that I'm going to write it clean rather than copying it over. So we're going to try to load the high score from the high scores that we've loaded into the game itself. Self.high scores, if you remember, we loaded them excuse me, when we started the game. We're going to try to look for the player in the keys of that dictionary, right? So there's self.player. We're using it as the key to access something in the dictionary. So if there is a high score for the player, then great. But maybe there isn't. And if there isn't, then we just return true, right? It's definitely the high score for the player if there wasn't an entry for that player. So then we're going to do the same thing that we did before, where we do a try, and then we do the weighted high. That we can copy over. Whoops. This whole block we can copy over. And we're just gonna change the high score here to, or high scores to high score. And the current, what do we need to do? Well, what is score? Score is not just anywhere, it's attached to the instance of the object, so self.score and self.score. And same deal, if there's a problem for whatever reason there shouldn't be, but just in case, we're going to return true. That's a high score. Okay. So we're printing the score, and then if self.check high score, so we're calling that right here. If that returns true, we're going to print new high score, and then self.highScores, because we have that thing, right, for the self.player is now going to be set equal to the score. And then game.update, we're going to update the high score with self.highScores. Have we written the update high scores method yet? No, let's go ahead and do that. That's going to be a class method. Def update high scores. And this one, like, this is it. Okay. All we have to do to turn this into an object-oriented instance is add a little CLS there, and also give it another argument, because update high scores now takes the argument of the high scores we're sending to it. If you go down to the game loop, right, we're sending the high scores over to it. So looks good. Pickle.dump high scores. Okay. So that's all. That's everything that happens when we quit the game. What about when we actually run the game? Of course, we need to break here. Okay, so let's say elif choice in game.beats. Well, the rest of it is pretty much just copy pasta, right? It is absolutely let's go ahead and let's actually make this a class method too, the handle result. Oh, sorry. Result. There we go. Actually, sorry. Just kidding. That's not what we're going to do. We're going to do it inline for now. So let's run the game. So computer choice. Yeah, that's pretty much what we want here. So the computer choice equals, remember we need to do game.getComputerChoice, right? And then result equals compare. That should be game.compare, because that's absolutely a class method. Let's make that class method real quick. I do apologize for the noise out the window. Some days it's just a little louder in this neighborhood than I prefer. So I don't know why sometimes Replit decides it's going to let me do my indentations the right way, and sometimes it won't. Okay. And there's let's write a self.handle result, so we're actually using our instance the way that we should. So remember, the handle result is where we update the score, right? That's what we had here. So we're sending the result in. Now we're not sending the score in because we don't have to. We already have it attached to self. So we just add self to that score, right? And then we're doing the handle result. And then print score, self.score. Okay, at long last, I actually think that we're done. We're going to run the game and see how it goes. But take a look here. And by the way, this URL will allow you to look at this code. And I will put it in the notes for the video. as well, so anyone can take a look at it. This is the longest one we've ever done, and this is the longest bit of code we've done, but this is kind of how it goes. Okay, let's run this game and see how we're doing. Great. Unexpected indent. It's been so many videos since we started and haven't seen an indentation error yet, but this happens in Python all the time. Line 97. Oh, because of that. Let's try adding a colon in the right place. There we go. Hey, all right. New game, enter player name, Taggart, choose one. Rock, we chose rock. Paper, why am I not printing out the result? Let's see. Print score takes one positional argument, but two are given. Oh, 23. Oh, hold on a second. Game. We're just doing a little debugging here. Ah, I forgot to add class as the first argument to our class method. That's one problem. And then down here, this should have been game.printscore, which is why I wasn't printing the score. Okay, let's try that one more time. Okay, new game. Actually, let's see if high scores has anything. Nothing. New game. Taggart. Choose one. Rock. Oh, because we're missing parts of the game, that's why. Let's see, computer choice. Self.handle result. Interesting. We got a new high score, which is writing sort of. So almost there. There are a few bugs here. I don't like to end the video on, so I know this is going long, but worth it, I think, to actually see how we debug a program. Okay, so what do we know that's going wrong? What should be happening? So when we go to high scores, first of all, it should be printing out the high scores, right? So I should be seeing this, and then I should be seeing the high scores. And it's not happening. So let's take a look at, for P and high scores, we should be printing the player name, okay, which is not happening. And then print score should be happening with the format right here. Now, I don't think this matters, but I'm going to put it up here anyway. I'm just moving the function just in case. Also, for organizational purposes, print score should be above print high scores because this relies on print score. So choice, let's go to rps.py. Oh, good job, Taggart. Okay, the reason why it wasn't printing is because we forgot to print, or I forgot to actually implement this in the main loop of the game, or of the program, not just the game. Yeah, so to do this, we don't use the new game itself because we haven't. We're going to assume that there is no new game, because you could load the program and just ask for the high scores without starting a game. So we're going to ask for the high scores from the game class with load high scores, right? That's why we made it a class method, not a game method. And then we're going to do game.print high scores with those high scores that we just loaded. So the reason we did that is so that it doesn't have to rely on a new game existing. Aha, see, there we go. Now that's working. So we're printing high scores. Now let's see about new game. Let's see if I can beat my score of nothing. Rock. Now I should be seeing, I should be seeing wins and losses. So that's the next thing that we need to figure out. Why are my wins and losses not getting updated? So it says, it doesn't say computer chose. So game.computer choice. Okay, that looks good. Something's going wrong with the computer choice. Let's confirm that we're actually getting into that function. I like doing this, just doing a print just to see if we're in there. Oh, now Q doesn't even work. Interesting. Let's try this one more time. So we're going to say rock. Wild. Now, can I queue? I can't queue. So something else is going wrong here. Game.getPlayerChoice doesn't seem to be giving me back what I want. Oh, of course it isn't. Let's So game.getPlayerChoice. Says your choice. Now, are we seeing that? Yes, we are seeing your choice. But if we choose Q, it says not a choice. How interesting. Let's see if the problem is in that function by changing it up. So we're saying instead of that, we're say choice equals input, choose a thing. Okay, let's just see if that's the problem. And we're removing the get player choice function from the equation, and we're using our own kind of shim. Okay, choose a thing, rock. Okay, Q to quit. So that's still not working. That's so interesting. Oh, wild. Okay, so I am seeing an indentation issue. Look at that. Welcome to Python. Oops. Okay. Let's try that one more time. So there was an indentation issue where the elif and the else were actually indented inside of the choice equals Q. I should have still seen something, but well, let's see what happens now. Okay, well, I'm hitting, so I hit Q, I got good game, final score, and this break should be out one level. That's why I wasn't stopping. Okay, so we do the stuff, we do the check high score, and then we break. So let's try that one more time. I think we're there. New game, under player name, Taggart, rock. Okay, new bug, but look, we made progress. Computer chose paper. Player choice is not defined in game.compare. That would be because it's not player choice, we called it. It's choice. Let's be more explicit in our variable names. Like so. Now, computer chose paper, I chose rock, I lost, the score updated, I won. If I quit, it's not a new high score because I guess I already had one win before, or it was a 0, right? Because it's wins minus losses. And look, I'm out back to the main menu again. If I ask for high scores, right? It's 0 and 0. And quit. We did it at long last. I'm so sorry it took this long, but we did it. All right, well, that was a good adventure in actually debugging code in real time. This is what happens when code gets complex, and this was for rock, paper, scissors. So think about what it's like to actually, build out a complex program. This is one of the reasons why. modularizing your code is so important so that you can keep track of small pieces and make sure those pieces work. And even here, right, we didn't even break 150 lines of code, but there were lots of ways that things could go wrong. But patience, right? We're able to work the problem piece by piece, look at the error messages and figure out what went wrong. And then at the end, we were able to get it to work. So I think even though this was our longest one, and we don't want to usually go this long, but I think it was worth it to dive into using classes and how to refactor your code to a new shape. And in addition, we added these features to our rock, paper, scissors. So I will add the link to this REPL so that if you want to check out the source code, you can, and modify it if you want. I think that's going to do it for this week. And if you're enjoying what we're doing and feel like giving back, again, I'm going to ask, please donate not to me, but to Human IT. They're a nonprofit organization that is providing low-cost internet connections and computing devices affordably to families in need, especially right now as we're about to ramp up for the next school year here in the United States. So if you can give either financially or old computing devices in pretty good shape, feel free to head over to humanit.org and help them out. All right, I think that does it until next week. Thank you so much, and happy hacking.